So here we are once again in PyData Salamanca. So just to let you know, we're gonna have today Manas Gaur, and Manas Gaur is a friend of mine, and I'm gonna be a little bit biased presenting him, but I'm honest too. He's a great person, and he's a Ph.D. student at the Artificial Intelligence Institute at the University of South Carolina in the US. So Manas and we were part of the Data Science for Social Good Fellowship in 2017 that took place in Lisbon. It was the first European edition, and we shared a lot of time together. But he is also a great machine learning researcher. He is specialized mainly in knowledge graphs, and he's going to talk about knowledge-infused learning today. And he's also specialized in natural language processing and also machine learning. But mainly he focused on applications to solve social good problems in domains such as mental health, cyber social harms, and crisis response. But most important of that, he is a basketball lover, as I am. And speaking about basketball, so this is a little spoiler, but in 2 weeks we will have a professional basketball player, Sergio Olmos. He will speak a lot, but he happens to be also a statistician. He does statistics analysis in basketball and sports in general, and he just retired. And he is gonna give us a talk about how we can analyze basketball data. So if you wanna see this presentation, it will happen in 2 weeks. But I stop talking about that. So for the people that are joining far away from Spain, just to let you know where Salamanca is. Salamanca is a little city between Lisbon and Madrid. We are mainly near the border. Manas couldn't visit Salamanca when we were in Lisbon, but he will do as soon as possible. I know, Manas.
After COVID.
Yeah, after COVID. So so we want people to give presentations. So if someone of the the people that are watching the video is interested in giving a talk, just contact us, and just that is all. So Manas, once you're ready, we are willing to learn about knowledge-infused learning. Okay.
Awesome. Thank you so much, Victor. First of all, I would like to thank University of Salamanca for hosting PyData, and our moderator, Dr. Victor, for giving us such a nice introduction about me and our mutual fondness in basketball. So first of all, like before I start the talk, let me just start our conversations with a very specific question, which we as a data science, as an artificial intelligence person, we more often encounter, which is why AI's adoption in real world, particularly in healthcare, is so challenging, right? Why there has been some issues. So when I say healthcare, we talk about electronic health records, we talk about social media, Twitter, Reddit, which has been like overloaded with a lot of conversations in healthcare, people seeking help, people providing help. And apart from that, we also see frameworks which have been used on these platforms for healthcare. For example, you can talk about conversational systems, making chatbots for healthcare, right? As Victor just said, in subsequent down the line, you will have one talk on the COVID-19 chatbot app. Apart from that, you have deep learning systems as well as recommendation systems. So one of the things that we share in common, Victor and me, is we had this work in data science for social good, where we were trying to relate patients and clinicians through our recommendation systems, and where we actually exploited the hierarchy in ICD-10, which is the International Classification of Diseases, 10th edition. So this is basically that whole area where we actually look at the healthcare, and the challenges is still alive. That why basically the AI's adoption in healthcare is still challenging. And in this presentation, I will be walking through you a series of work and applications which me and my colleagues have done, particularly in healthcare, with the whole goal of involving the background knowledge. And when I say background knowledge, they can be graph, it can be human in loop, or it can be simple kind of a lexicon or kind of a dictionary that you use to actually motivate your research and actually helping your deep learning algorithms to work better. So our outline of the today's talk would be twofold, very specific on motivation. So first of all, I will be motivating you on the knowledge-infused learning. I'll be providing some concrete definitions. How do we use knowledge graph in applications? Providing a little mathematical background. I know it's late in Salamanca, and but it's kind of a lightweight mathematics and not too much in details. I will be talking about some kind of types of knowledge-infused learning, like what are the different types that we came up with, different categories of knowledge-infused learning. And the fifth point, which is pretty essential and would be the key takeaway, would be the models, evaluation methods, and applications. So where they have been used, or there are some other areas where there's which hold potential for knowledge-infused learning. And then I will talk about the knowledge-infused learning for healthcare, giving you some of the challenges that myself encountered in the data sets, and a project which actually I worked on, bridging the gap between Reddit and DSM-5. Where I say DSM-5, it is a diagnostic and statistical manual for mental health disorders, which is basically a kind of a holy grail for the clinical psychiatrists. So this is something that they often use in order to treat their patient. So just wanted to see how we can actually map Reddit and DSM-5. So moving on further, let's have a definition for the knowledge graph. What is a knowledge graph? A knowledge graph is basically a structural representation of knowledge. Let's say we have, in a very simple sense, we can think about apple as one of the concept, and then there's red apple, there's green apple, and there is like orange apple, or there are like different colors of it, different categories. Something very similar, you have the purse, or you have this let's say kind of a concept, and there are different variants of that concept that are actually related to that main concept. So you kind of do a hierarchical representation, which is more like a structured knowledge. And it happens is that it occurs in Wikipedia. When you open a Wikipedia, on the right hand side you have this info box which provides all the details, all the different concepts and the values of that. So those are like you can say those are the visual representations of knowledge graph. This knowledge graph actually helps you, and there are series of work on this in the past, on semantic browsing, personalization, recommendations. Because you want to do a personalized recommendations, one of the things that Netflix does it based on the reviews and your comments. Amazon does it. YouTube also has it, because based on your keep on watching some particular video, it kind of learn and also recommend you some things very similar in content. And the summarization. But more importantly, the knowledge graph's role lies on solving two very specific problems, which is data sparsity, because not all the domains, not all the problems in healthcare specific have a very nice curated data. That's the biggest challenge. And data sparsity is one of them. And ambiguity. And ambiguity comes as kind of an occupational thing, where when a clinician is interacting with a patient 1 and a patient 2, they might be suffering from the same disease, but they are explaining themselves in a different way. So here is the lies ambiguity, which our brain solves it based on the background knowledge that we have. But how we can actually use that kind of a structure, that kind of a mental model in solving some real life problems, that's one other challenge that is raised by that is basically highlighted by me as considered as ambiguity. So that's another challenge where actually knowledge graph plays a key role. So there are different forms of knowledge graphs in specific. One is ontology. When I say ontology, means I have a graph, I have a knowledge graph, and a human person or a human or a domain expert curates its entities and relations. So I know that whatever is present in the graph is validated by humans. Another is a knowledge base, which is a flattened graph, and you can consider them to be relational databases. So I'm using a relational databases. For example, let's say I make my model, which actually simultaneously in parallel queries a database, gets some additional information, augments that information to its current stage or current procedure, and it tries and it improves its learning. So it's gathering more information and more knowledge from the relational databases. That's another knowledge base. Lexicon, which is another version of a knowledge graph, which is also a flattened one, but it is very application specific. You create it for a very specific application where you want to use it, and it is not generalizable across different applications. For example, if I wanted to create an anxiety related lexicon, which is the most common cause or issues in COVID-19, anxiety lexicon is there, so you can actually create one of them, or you can create a depression lexicon very specific to understand the depression trends in COVID-19. There are general purpose knowledge graph, which is humongous, and which you can use just to filter your content and make it more specific. For example, DBpedia, which is a graph of Wikipedia, Yago, Freebase, ConceptNet is a multilingual knowledge graph, which have been developed by MIT Common Sense Lab, and it's kind of a spin-off from the MIT Media Lab research. Then you have Knowledge Vault. NEL is a never-ending language learner hosted by CMU, and Wikidata, which is another curated form of the general purpose knowledge. So you get your information about elections, you talk about information about pandemics, you can talk about disaster scenarios, so all those informations are present in these knowledge graphs. So when you're dealing with those problems, these are the general purpose knowledge graphs that you can actually leverage to improve your deep learning procedures. Now, when we talk about healthcare, there are very specific knowledge graphs. So first one is the SNOMED-CT, which is basically the nomenclature, unified medical language system, which is which is another relational databases providing the concepts, treatment, diseases, procedures, findings, as well as symptoms. DataMed is basically an API made by NIH and University of California, San Diego, and I have given a link to in the bottom of the presentation to how you can access it. It's a very fairly accessible API, but requires some kind of like a filtering at the top of it. ICD-10, RxNorm, which is basically the drug-related database, and it's also a knowledge graph because they are actually converted into some kind of entities and relations and subject, predicate, and object triple kind of thing. So where you have the subject is one of the disease, and object can be the symptoms, and the relationship can be defined by the domain experts. So the drug bank and drug abuse ontology and medical dictionary for regulatory activities. So these are like the more very specific knowledge graphs which have been used in the healthcare. Some of them I have used by myself as well as I go through in the subsequent slides. Let's take an example of how these look like. So on the very left is a common sense reasoning graph made by Allen Institute of Artificial Intelligence, which tells you that if you have any statement where X repels Y attack, what are the different ways you can actually express it. In the middle is a drug abuse ontology, which talks about how people express themselves, especially people who are suffering from drug abuse issues and addictions on social media, and how we can actually use the domain experts' knowledge along with the native language these people use in social media to actually make an understanding of how we can express them and how we can understand what exactly they are facing from and what are the diseases and how they're expressing, whether they are the people who are addicted, whether the people who are actually having some hallucination because of they're taking some sedatives, what are their behaviors actually is we can actually express from this ontology. Then the third one is an event ontology, which is also created using the cognitive theories, as well as it's a kind of it is basically built on the Levin's categorization of events, and it's pretty interesting to see how these events are being linked to each other, and you can actually use these ontologies to actually make your data, your basic structured data in healthcare records, are basically your data in the social media, make it more meaningful using these ontologies. And the fourth one is basically the crisis ontology, which express, like for example, a person is talking about affected population is one of the tweet that is coming there. What are the next possible tweet that should be associated with it? People will ask for volunteer support, people will ask for service, People will report trapped people. People will show about missing peoples. So these information, if you are accumulated together and summarize them, it will be helpful for the end user, especially the domain expert, which is the emergency responders, to get a better decision or the better understanding of the situations. So another example where we can actually use this knowledge graph is the personalization, which is a very fascinating thing, specifically in COVID-19 as well as in mental health care. Because when we say personalization, means we are actually giving a decision based on the data that you are giving me, and which is very interesting because that would require a very extensive use of the knowledge graph. The reason is because over here, as you are playing with the chatbot is gathering your information, making a graph, so that next time when you interact with the chatbot, you're able to get meaningful information, and your conversations is more like is not like a kind of a question answering system. Is more like a conversation, like a dialogue flow. So now the here challenge where current chatbot have is, without personalization, without personalized knowledge graph, it gives a very generic information. But with knowledge graph, it is more meaningful because it is able to understand what you are actually asking and relate it with one of the information being present in the database, and so that it can give you a more specific information or more, and like even it's kind of like you can consider it like a reinforcement learning system where user gives an input, the system realizes that input, give a more generic output, more understandable output, and actually the conversations happens. So this actually brings in user engagement, because then the concept of reflective listening, which is one of the major parameters in the clinical setting, comes into play. Now, another application where we have used knowledge graph in a very recent work is assessing the mental health impact of COVID using news articles. So what I essentially did in this work was we actually brought together all the news articles around the globe using the GDELT database. Now, this news articles are in multiple languages. We used a multilingual knowledge graph, as I said in the previous slides, a ConceptNet knowledge graph, and that knowledge graph converted this all the languages into English, maintaining the semantics. Then we used an off-the-shelf neural parsing mechanism with self-attention, which is basically a parser, an NLP parser, to actually extract three very critical things: verb phrases, which describes the events; preposition phrases, which describes the intensity of the events; and the noun phrases, which are just conjugated entities. And this is consider this to be a very huge, a large set of information. Now, what we did was we parsed this information through DBpedia to find those entities which are actually understandable by people. Right? We actually use DBpedia as well as UMLS, which is the Unified Medical Language System, to identify those entities which are either related to healthcare directly or indirectly they are related to healthcare. So that forms a filtered set of entities. Now we categorize these entities by states. You can act for that. You can actually use another ontologies, or you can actually use off-the-shelf some of the APIs which are there available to actually find what are the different states. And in this thing, what we did was we actually looked at the states mentioned in the news articles, and that's how we categorize them. And we filtered this set of entities using PHQ-9 and DSM-5 lexicons because we wanted to be very specific to mental health, and it is very hard to go very specific to mental health in DBpedia and UMLS because they are general healthcare systems and general purpose knowledge graph. To be very specific, that's why we use PHQ-9 and DSM-5 lexicons. And I said before, lexicons are very specific to applications. And then we actually looked at the different trends. In the first week, what happened; in the second week, what happened; third week and fourth week I think this analysis was actually done for the period of March, for a few weeks of March and the first few weeks of April. So that's how the analysis was actually done, because that was the dominant phase when COVID-19 was at rise in USA and major part of the states. Another work that we actually did where we utilized knowledge graph was to understand the gender-based violence. So when the gender-based violence is, you can consider that to be a causative agent, a causative phenomenon of mental health. and particularly we did it for Twitter conversations. So what we essentially did was we actually leveraged a gender-based violence lexicon. We mapped that lexicon through to DBpedia, and then we filtered it based on, and then we looked at some of the categories which are relevant to those terms. We organized this lexicon based on the categories in the gender-based, so using the words in the gender-based violence lexicon. And then what we essentially do is we calculate a cosine similarity between two vectors, one vector from the lexicon and one vector from the tweets that are being dispatched or that have been published on Twitter for the period of March 14 to April 4. And then what we essentially do is we actually create a gender-based violence index where we have a tweet and its score or to the what level the gender-based violence is being present in that tweet. And then we use a maximum a priori estimation algorithm, which is a map algorithm, which is pretty interesting because we have, and the reason I wanted to do, we used MAP and not MLE was because MAP is very specific to the problem that you're using, and it only works on the observed data and not on the unobserved data. So right now we just wanted to focus on the gender-based violence only in COVID and not any other domain. So that's why we only focus on map estimation. So we did an estimation for 14 days, and which you can see in the lower end, there's a plot. So where we actually saw that before March 14, the gender-based violence was nearly 5%, but during the COVID-19, due to multiple events that are happening, it rose to 58%. So with all these knowledge graph related activities and the knowledge infused involvement in deep learning, let me give you a very concrete definition of what I meant by knowledge infused learning. So knowledge infused learning is the exploitation of domain knowledge. This domain knowledge is in the knowledge graph, can be knowledge base or can be human in loop, and application semantics. Basically, we want to preserve the semantics in every transformation that we do on the data, and with the holding that we improve the deep learning methods by infusing this knowledge, by infusing relevant conceptual information into the statistical and data-driven computational approach, and which is basic kind of analogous to a kind of a buzzword which is neurosymbolic AI, right? Where you actually bring in the symbolic information in terms of logics and rules, which are there in the domain, in the knowledge graph, and the neural processing, which is given by the deep learning algorithm. So this forms the whole crux, the whole definition for the knowledge infused learning. Now, why actually, as I said in the very beginning, we have the data sparsity issues and ambiguity issues. But apart from that, the major issue that actually drove my attention to knowledge infused learning was probably approximate correct learning, which is a PAC learning. It's a very old phenomenon around like dated 1984, 1985, and revised by Dr. Leslie Valiant in his recent work on robust logics in 2000. So PAC learning says that in the real world data, you have the real world training data is humongous, and it is computationally hard to actually find the area where you can actually get the best outcome of your model. So in this equation, if I wanted to make an understanding of it, is you want your test error to be acceptably good, like and you want the training error to be as close to zero. The number of hypotheses that you will be generating in order to achieve this state is exponential over the number of samples that you're putting on your training sample on your training in your training model. So the exponential number of samples that you are actually taking, that makes this entire process computationally hard. And there are many turnarounds, there are many relaxation that you can do. For example, you actually minimize your misclassification error. You say that, okay, let's say 0.2 is sufficient for me, 0.4 is sufficient for me. That's kind of like you can actually relax that kind of thing. And you can also put an empirical threshold, which is a human annotation error. Like, what is the error that human will often most probably will do? You use that to actually reduce your training times, and you also reduce your search space. So those are like the things that you can actually work around to actually minimize your training times. But essentially, this PAC learning allows you to do following. It will tell you whether the training data provides a good domain coverage, whether the model trained is a robust, having a low generalizability error, and it is a consistent classifier. That means it has a low training error. And what it entails what you can actually get from this, which helps you actually in getting your system out in the real world, is confidence and complexity. You have more confidence on your models, because that's how it is being evaluated. And the complexity means the less complex is the model, the less number of samples it will require to train. The more complex your model is, the more number of samples it will require to train. So that's a trade-off, and it is often seen in the deep learning paradigm. So this PAC learning behavior actually helps you to to develop a model which is actually will help you in evaluating your data, evaluating a model, and seeing its visibility in real world. Let's in this knowledge infusion process, what essentially when when we are looking at the PAC learning, so PAC learning is just talking about this motivation that this data set is you are actually trying to what you can say that you are actually trying to reduce the complexity of your model. You're trying to make it more generalizable. Essentially, the biggest challenge that PAC learning highlights is the association between the true data distribution and the hypothesis data distribution. Hypothesis data distribution is the distribution that your model learns, and the true data distribution is basically the data that is there in the real world, or that on which your model is training. Existing machine learning model, what they do is you give your data D to your model. It will learn a hypothesis distribution by minimizing the distributional difference between these two. The challenge lies when the labels that on which your model is training is not 0 and 1, but there are some labels developed by the human annotators by using their own knowledge. If that happens, it is very hard for the model to actually achieve a certain level of accuracy, and that becomes a biggest challenge in its adoption. Infusion, on the other hand, will help you out in trying in putting a gap, in actually bridging the gap between the true data distribution and the concept, which is based on or the target variables on which your data is or basically the target variables which are used to actually create your data. And it tries to convert this entire complex of dx and cx into dx and cx are converted into basically there's a gap between these two, and based on some empirical threshold you give your output level as 0 and 1. And this entire process again falls into the old paradigm on which your machine learning models are very well in understanding. So this knowledge infusion is basically a way where you can actually bridge this gap between the domain data and the concept class. So there are different types of knowledge infused learning, where we actually, and these are the categories that we came up with based on our recent literature survey that we actually did. One was a shallow infusion, another is a semi-deep infusion, and the third one is a deep infusion, which I will very briefly touch upon. In the shallow infusion, what essentially you are trying to do is there's no messing around with the deep learning model. What you essentially try to do is you enrich your data set, and you get some hypothetical information, which is kind of a hypothesis data distribution, which I wrote it as a tacit knowledge, which is basically a learned knowledge. And you try to find a similarity between what the external knowledge has and what the model has learned. So you can use a hypothesis testing or similarity based verifications. Moving on to the semi-deep, here you actually mess around with the deep learning model. You actually bring this external knowledge into the machine learning model, or into the deep learning model as a form of attention. So when you put the knowledge as a form of an attention, this process generates a weight matrix, which I represent as a W. And what you essentially do is you have a weight matrix for the tacit knowledge or the learned knowledge, and you have a weight matrix learned by this thing, by this self-knowledge or self-aware knowledge or external knowledge, and you try to find a similarity between these two domains, these two outputs. So what you're actually saying is that there is a weight that I generated based on my self-aware knowledge, and there's a weight which is generated by the deep learning model, which are kind of, you can consider them to be a kind of a heat map, kind of a M cross M, a square matrix. So you have two square matrices, and you can actually calculate a cosine similarity between, or a similarity between those two matrices. So that's very simple. In a very simple sense, you just want to verify how well your model learned your self-aware or external knowledge representations. So moving on to the shallow infusion. So as I said in the shallow infusion part, it is more like improving your data. So when I say improving your data, it happens through word embeddings, word to vec, which is a very popular, extensively used method. Glove, which is another variant of word to vec. Retrofitting is another method where you actually use a semantic lexicons, as I said, PHP9 lexicon or DSM5 lexicon, and you change the embeddings of word to vec or glove. That's retrofitting. Fast text is another character level methods that have been also being used for improving the data sets. Counterfeiting is another way of very similar to retrofitting using the lexicons. And the current trend in 2018 and 2019, which goes on to the transformers. These are all ways of generating the embeddings of your data. And how they do it is you can actually bring your knowledge base, your existing knowledge, or in kind of a relational database, a knowledge graph, and you can concatenate them with the information that's in your training data. That way it enriches your training data or your input, so you get better representations, and with better representation there's a possibility that your model will have a better precision and recall. So these are like the ways in which you actually work around on your data set, on your improving your input training data. The semi-deep infusion is the methods are basically more of forcing methods, which is teacher forcing, professor forcing, neural attention models, which are self-attention and neural guided, knowledge guided neural attentions, LSTMs with knowledge graphs or knowledge base, and knowledge based GANs. So these have been the recent very few very specific work that act on using the background knowledge in improving the classifications. So this is a kind of a very visionary architecture of deep infusion or deep infusion of knowledge that we thought about, as where we actually try to improve your learning. So essentially what it does in a very abstract sense is as follows. When your model is training, your deep learning model is training, it goes through a series of layer, and each layer has some hidden units, and these hidden units have hidden representations. But it has been stated in the past as well as in backpropagation algorithm that there is information loss when the model is training over multiple layers. This information loss can be actually regulated through a kind of a knowledge graph which is in parallel, through a kind of a function which you can actually use in a very simple sense is a Kullback labeler divergence, which is KL divergence algorithm, which are KL divergence function, which tries to find the information loss between what's in the hidden layer and what's there in the output knowledge. And that you, for now, very simple sense, you can actually replace this knowledge graph with your input data only. So you want to just make sure that your layer is not losing knowledge and it is retaining the knowledge as it's training. So that's another that's actually a way where you can actually use knowledge infusion, and you can actually use the output, and with the knowledge graph it brings in explainability and interpretability in your outcomes, so that you can explain, oh, this is the graph that I have, and these are the nodes within the graph that were actually most visited while training. That means that these are the words that are being most often touched upon by the model while it's learning. Let me see whether those models, those nodes are actually useful for the domain experts. So that brings in the real address a real way of addressing the issues of adoption of AI in healthcare. So among all the different ways in which the knowledge-infused learning can be modeled, I will just give you a brief, a few models that I would suggest. I myself have tested, and they have actually worked well in terms of knowledge infusion. One is basically the LSTMs, which is the long short-term memories. So what I essentially does is that among various variants of LSTMs, if you can see in deep learning, like for example, there are many to many LSTM where whatever inputs you have equal number of outputs, and which are very similar to an autoencoders. In this case, what I have shown you in the figure is more of like a many to one LSTM. It learns through a sequence, and it has one cumulative sequence at the very end. And what essentially we are trying to do is we'll take that sequence and a sequence preceding that and some kind of a knowledge representation and pass it through a simple multi-layer perceptron. In this case, the knowledge graph representation acts as a bias. in training a multi-layer perceptron to generate a new representation MT, which is basically a representation involving the training data as well as the knowledge graph. So this is one way of putting your knowledge-infused learning. Another way, which I haven't tested it, but it should be interesting, would be 1D convolutional neural network, which can be used for mixing. So right now, what I have done is for multi-layer perceptron, you can replace a multi-layer perceptron with one-dimensional convolutional neural network for mixing purposes. Another version is to transform this entire architecture using a graph convolutional neural network, which exploits the hierarchical structure. This is very much important if your application requires the preservation of relationships between the entities while prediction. So that's where your graph convolutional neural network plays a key role. Another model that I was very fascinated with, it came up in a recent work by Dr. Chang at Stanford University, which is basically the knowledge-guided generative adversarial network. What essentially it does is that you have training data of scene categories. That means assume that this thing that you have. Their framework was actually built to understand the data of stroke patients, patients who have been suffering from strokes, and there are different variants of stroke, like ischemic strokes and hemorrhagic strokes. So in this, what they essentially did was they have the data on the stroke patients suffering from ischemic stroke in the scene category data, and they do not have the information on the hemorrhagic stroke patients. So what they essentially wanted to do is how well the model gives the treatment outcomes when they pass this unseen categories along with the seen categories and train a generative adversarial network that gives a prediction for the seen categories, which is the ischemic stroke as well as the hemorrhagic stroke, without having a labeled data for the hemorrhagic stroke patients. So essentially, this entire architecture, the major important part was the discriminator. Obviously, it learns over the real and fake data. What essentially it does is that it looks at the embedding regression network, which is kind of, it takes the parameters of the generator 1 and the parameter of generator 2, and sharing of these parameters, it does two predictions. One prediction G1 and another is a prediction with G2, because those two are the two different generators that we have actually trained. So you have three different laws, and at the end, what we essentially do is we actually look at the cosine similarity of the information loss using the KL divergence, or using the cosine similarity as a function to the similarity between the two. So when I say prediction is an embedding, and prediction of G2 is also an embedding prediction. So what essentially you're doing is you're trying to find the difference between the embeddings that you have in your semantic embedding of the unseen categories, which you can actually find from PubMed abstracts. You can look at for the knowledge graphs in the healthcare domain, and you find the difference between them using the KL divergence or cosine similarity. So essentially, the objective function of this entire architecture goes on to that you have the simple GAN, but over here you add this simple GAN with a regularizer, which is where I say SE is basically semantic embedding of the loss incurred by the generator 1 and the loss incurred by generator 2. So this network actually tries to predict the severity of hemorrhagic stroke patients based on the severity analysis of ischemic stroke patients. So this was a very interesting work on using the generative adversarial network in healthcare domain. With all these architectures and models in place, what specific is a key takeaway that you can get from this work on knowledge-infused learning? The major objective function that people have used is a KL divergence, which is Kullback-Leibler divergent functions, because it actually helps you to measure the information loss, and it is insensitive to the distribution of your data, which makes it a very important objective function. Knowledge graph embeddings can be developed from various approaches, such as whole-I and trans-I. Different models can be used for knowledge-infused learning: various autoencoders, LSTMs, GANs, and Siamese neural networks. In terms of framework, you can actually model your problem as a zero-shot learning, one-shot learning, transfer learning, and parameter sharing, where the knowledge graph plays a key role. Other variants of an objective function that you can take, along with in spite of taking the KL divergence, is Jensen divergence, which is just a variant of KL divergence. Regularization, as I said in the previous slide, regularization is another way you can actually bring in the knowledge. And integer linear programming, which is definitely a very nice way of bringing in constraint in your data. In terms of evaluation, what essentially you can actually look into when you're doing knowledge-infused learning is before the knowledge infusion and after the knowledge infusion, what exactly the model is doing. There are different methods. One is a Frechet inception distance, which is very popular in images, but it is also possible to use in the textual data. Statistical significance hypothesis testing, which is basically you have one representation from your training data, one representation from a semantic resource, and you find the how well they align or how well they differ. Where they differ, what is the information loss, and can that information loss be added through a concatenation or some dimensionality reduction technique applied after concatenating those two representations. You can also report word and concept features that the model is putting its emphasis, and seeing whether that model is those features are actually important to the domain expert. TSNA visualization of clusters, area under the perturbation curve, which is a pretty interesting topic, and I just got to know in the previous I think couple of days only, which tells you that if you have like say 100 features, if you remove 20 features out of it, the remaining 80 features, how will your model perform? So if you remove 40 features out of it, in the remaining features, how your model is performed. In this way, you can actually find which are the features which are actually important, and then you can have human in loop to test whether those features are important or not. And above all, you can always go for human-centric evaluation, which is crowdsourcing, user satisfaction, mental models, and trust assessment and correctability, whether my results is correct or not. For correctability, you can actually go with Cohen's kappa, which is one other inter-annotator agreement measures. In terms of applications, so we already covered the definition, we covered the methods, we covered the evaluation and metrics, and now we move to the applications of the knowledge-infused learning. The applications, there are a bunch of it. I will try, I'll go over like a couple of them. One is the summarization process in the clinical diagnostic interviews. When a clinician is seeing a patient, right, he has no clue about his mental health patient, his concern, his status, and he starts with some initial interviews. The interview, as you can see on the top right, is basically the start of the interview, which is basically more casual, just random questions. Middle of the interview is very specific, asking very specific questions, and the end of the interview is also kind of very specific, but it will be helpful if you can add it to the summarization stuff. So this entire structure, what it essentially does is that it takes those conversations into account and find an area within that conversation which is very much informative for the clinician and summarize that part, and that summary is given to the clinician for evaluation. In this process, what I have used is the integer linear programming. As I said before, it's a very fascinating framework which allows you to optimize the things which you want to optimize. For example, my summaries should have high linguistic quality and they should be informative. That's in terms of from the clinical perspective standpoint. So that's what we optimize in the ILP summarization task. In this process, we pay focus on the terms which are very much important to the clinical to the clinician. And how we do that is through a measure which we call as a word semantic scores, which we create using the PHQ-9 lexicon and the ConceptNet vocabulary. The ConceptNet, as I said, is a general vocabulary which has large number of words. PHQ-9 is very specific to the application. What we wanted to do is we want to give the weights to the terms which are very much important and give low scores to the terms which are not important for the summaries. And as you can see an example of SAD and insomnia, which are very much related to depression and distress, are way higher than the terms like lawyer and male, which are like not that much relevant, are giving low scores in the word semantic score index. So that would help the ILP method to actually do a better job in summarizing the interviews. And when you look at the visualization of how these things work, as you can see, the BERT, which is a very famous deep learning algorithm, is not able to understand what exactly happening in the conversations, and it takes the terms which he thinks with the model thinks basically is important. We move with an abstractive summarization using integer linear programming with some constraints, as I said, the linguistic quality and informativeness. Right now we do not use domain knowledge, but when we use domain knowledge we get more concrete summaries, as you can see very in this example. For example, the patient was asked how long ago were they diagnosed depression. Participants said they are still depressed, which is kind of not relevant as a response to the question being asked. Whereas when you say on the using the PHQ-9, you say how long they were diagnosed with depression, the participants said a year ago, which is basically kind of a more appropriate response to the question being asked. And there are many other questions which the model without the knowledge ignored those questions and responses, whereas the model which takes the knowledge gathered or captured those questions and responses. Another application where I actually used knowledge-infused learning was to find an association between social media and electronic health records. In this process, what we did was we actually had the suicide watch subreddit data of 93,000 users and the New York City CDRN, which is the Clinical Data Reserve Network, on the EHR for the electronic health records for 123,000 patients. We projected this on the TSNE class visualization along these categories: depressive feelings, psychological disorders, drug abuse, and many other categories. And some similar categories were there in the social media as well. And what essentially we wanted to see in this, which is a very concrete example of why the knowledge-infused learning is required in healthcare, is that we identified self-harm, depressive feelings, and suicidal ideations as a latent topics expressed in Reddit as well as in the EHR data. And another thing we found was both the sources did not provide evidence of mentions or expressions of impulsivity, family violence, and drug abuse. So they were there, but they were not actually being shown in a very large sense in the data. So that actually gives us the way of analyzing how social media needs to be used in EHR and how EHR can be benefited in understanding social media and vice versa. So you need to have this background knowledge, which we gather from SNOMED-CT, DataMed, ICD-10 as the major resource in understanding these behaviors. So with this in the mind, in the motivation in mind, we step into the knowledge-infused learning for healthcare. I will be speaking around two specific things: challenges and the classification of Reddit post to DSM-5. So the first challenge is the contextualization, and it happens at the user level across so in this contextualization process at the user level, assume that a user has posted at some, so the number that you can see S8 and S5, you can assume that I have 15 sources of information, and this user has posted in the 5th source, and there's this user has also posted in some 8th source. And you can, in a very, if you want to kind of like a pedagogical example, consider them to be subreddits or some like 15 forums where this person has shown his interest and gave the post over there. So if I take the post of this person, let's say on the left hand side, I don't think I have thought about it every day of my entire life, and I have for good proportion of it. However, my boyfriend and whatever issues are there, you take this post and you give the model, and your model gives a prediction, right? The prediction is, so the person is having some indication of suicide. He may not commit suicide, but he has some indication of suicide. But what happens is that when I bring his another content in the past together, right, or it can be the content that he posted on the same day itself, but in some other forum, if I bring that content, I get a different representation because we are bringing the context. The context is basically the description that the user is giving, that basically the model is not aware of that initially, but if you can bring it, it's some additional information. It's kind of an additional directions or pointers that will help the model make a very well wise judgment, and not some kind of a random judgment which is basically more fragile and brittle and is basically hinders its adoptions. So that's basically one challenge in healthcare, is the contextualization. You want to bring as much context before you actually train your model, and that context needs to be very much similar to the basically the problem that you're actually trying to solve. For example, if the person is is showing depression, so if you want to predict depression in it, definitely suicide related content might be important. But if you bring the suicide content, then your model will not predict the depression severity, but rather it will predict the suicide severity. So you want to be very cautious in bringing the context. So that's the one biggest challenge in the healthcare. Let me give you another example, another challenge, which is abstraction. So abstraction always go along with the contextualization. So you wanted to do is, so contextualization, as I shared in the previous one, this is bringing the post back along with the current post. You want to bring them together. What I have shown on the left hand side is a graph. Let's say I'm talking about suicide watch subreddit, where people are talking extensively on suicide related terms and suicide related communications. What I see is stop self harm, which is I represent SSH. Abbreviations of like the full form of all of this thing are given at the very bottom. Stop self harm, borderline personality disorder, schizophrenia, anxiety, addiction, and depression and bipolarity has some contribution. This person has talked about in all these forums, and when his content when he's talking in suicide watch subreddit, I could relate his conversations, the way he's conversing in the suicide watch, with his conversation in other forums, and I wanted to bring that conversation over here so that I can have a valid, a wise judgment, a correct judgment about this person's suicidality or suicide risk severity. So that's the way, that's the whole job of contextualization. Moving further, we look at his user's content. I found myself mired in a similar situation as your boyfriend, addicted to the internet. It sounds like he's hurting a lot and needs your help in changing its habit. We know that there is some addiction issues, there is some depression related content, but this is a clinician would take a time to actually understand and decipher what exactly the person is trying to do, and maybe require multiple iterations of it. So what essentially abstraction does is like transforming this content into keywords, into terms or concepts which are more relevant to the clinicians, and they can make a wise immediate judgment on what the person is talking about: drug abuse, hyperactive behavior, and depressive mood. So these are the main attributes that describe that patient, and with this in mind, you actually do the model will do a better job in prediction. So that's the transformation of this very absurd content into a more very specific content is what the job of abstraction is, and which we use with these kind of resources that you see in the Kubadle box. Now in this, so you have seen me talking about social media data and EHR data. Is there a way to actually have a map between these two? Yes, there is a map. So if I can take a social media data in terms of like social media platform like Reddit, and I talk about what I have seen, which you have seen in the past, that I have talked about SNOMED-CT, ICD-10, DataMed, Twitter ADR, drug abuse ontology, Ask a Patient, DSM-5 lexicon, and suicide risk severity lexicons. These lexicons provide some very concrete information in the EHR data. So what you see in the green box is the electronic health records information. Electronic health records provide you the treatment information. They give you observation drug related information. They also provide mental health conditions, and they also provide your risk levels, ideation, behavior, and attempt. And these all informations can be gathered from these lexicons, which give you the power to actually bring the social media data with the EHR data, and to actually understand the synergy between these two platforms, and see how we can actually leverage these data through this knowledge graph and handle the data sparsity problem and handle the ambiguity problem. Now, in this task for the knowledge or moving or mapping the Reddit to DSM-5, the classification of the Reddit content to the DSM-5 disorder, the task that I was very much curious about was, given me a content in a bipolar subreddit, how I can map that content to a DSM-5 category, which in this case is a depressive disorder. I do not make changes in the data set. I do not make change in the content of the user. I just change their labels. So essentially what the task transform into, that I have all these subreddits: bipolar SOS, depression, and what essentially these 4 subreddits are being mapped to the depressive disorder, the DSM-5 category. This is essentially what I wanted to do. And subsequently, addiction, crippling alcoholism, opiates recovery, opiates, self-harm, and stop self-harm are being mapped to the substance use and addictive disorder. There's a possibility that stop self-harm and self-harm also associated with suicidal ideations and behavior. But in just kind of an example sense, you can actually map them. They are also equivalently responsible for suicidal substance abuse and addictive disorders, and which also further can associate with suicide. So you can actually look at the trail blazing around with this mental health conditions, right? And you can actually have this chain which you can actually exploit for better understanding and explainability and better outcomes. So we know, so just this slide is actually I made for people who might not be aware of Reddit. So Reddit is just a social media platform which people talk about, gives the main post, which actually starts a conversation. People give comments and then replies. We actually scraped this content, or we gathered this data from the period 2005 to 2016 with 550k users, 8 million conversations, and 15 mental health subreddits. So when I say 15 mental health subreddits, consider them to be 15 different forums, something very similar to what you can see in the figure in front of you. So in this, the crawling, I just wanted to say out. In the last talk at the PyData, which was given by Hui Zhang, who talked about the beautiful soup and scraping of the social media content or scraping the web, something very similar which we used in scraping the Reddit to actually gather the data for different mental health subreddits. So that's kind of a very interesting way of gathering your own data for your own prototypical understanding of how this data can be used for healthcare purposes. So when I say Reddit to DSM-5 mapping, I have, so essentially what I'll just be recollect. So as I said, the task is that you have the data with a bipolar subreddit, and you are being mapped to another content, which is basically the DSM-5 same content with the different labels. How we gonna do that? So that's the task in hand. So what essentially wanted to do is, we have this data with Reddit post in the subreddit label. As I said, the previous example is a bipolar subreddit label as one example. We pass them through n-gram model, LDA and LDA, which is basically the latent Dirichlet allocation, which is basically a topic model in the natural language processing world. And what you want to do is, you have this representation. As I said, always we create a representation, an embedding vector, a feature vector of any dimension that you feel good. It depends, and it's adjective.
You have 2 minutes.
Yeah. So, and we create a normalized hit scores. This normalized hit score is basically the similarity between the representations and the n-grams, and this representation of the subreddit. And essentially what you want to create is basically you replace the Reddit post with the DSM-5 label that is of the highest similarity with the representation what you see in from the n-grams, LD and LDA over bigrams. So in this process, the workflow is as follows. You see Reddit with DSM-5 labels that you created in the past. You pass into a word embedding model. You have this background knowledge. The reason I wanted to use it, because they have been used in mapping the Reddit to DSM-5. So I need them to actually make sense of whether the model is able to understand this mapping. So what essentially you're trying to do is, you're trying to find a correlation between the words in the Reddit, correlation between what the DSM-5 concepts are, and what essentially you want to do is a mapping from the Reddit to DSM-5. That is a cross correlation, and you want to optimize this process. And at the end, what you get is a vocabulary matrix, which is a matrix between the words in the Reddit and the DSM-5 concepts, and you modulate your word embedding. Basically, you change the word embeddings, right, with these scores, and hence you do the classification. And optionally, you can actually add linguistic features as well. So essentially what you're trying to do in a very mathematical sense is that you have the Reddit words and you have the DSM-5 categories. Essentially you want to learn this W in the middle, and you have different word embedding models which you can use, and you actually try to learn this W, and which is basically kind of a optimization function between the Reddit and the DSM-5, which is represented by D. And for the part of that equation, the first after the min W is the encoder, and on the right after delta is the decoder stage. So that's why we call it as a semantic encoding and decoding optimization. This is just a derivation of the semantic encoding decoding optimizations. So what happens is that with this approach, we are able to see that an existing up method, which completely dependent on the lexical and syntactic features, gave 30% false alarm rate. And with our approach, which uses this contextual features with DSM-5 and DAO, which we do not even use linguistic features at all, we get for 2.5% false alarm rate. And it will go further down if you do linguistic features, but I doubt that, because it depends how discriminative are those linguistic features. And it is completely data driven, so it brings in more explainability and ease in your methods, because now you know how the model perform well when which are the specific words that the model used in its prediction. So to end my talk, I just wanted to actually give you a series of resources which I have used, and I have even built with my collaborators over this time, particularly to understand how the knowledge-infused learning can be used in understanding healthcare and making systems which are more close to its adoption in the real world. So to end the talk, finally, I just want to summarize where are we and what's happening in the world right now. So as I said, the current research focuses on background knowledge, focusing on shallow infusion and semi-deep infusion. Explainable AI in healthcare falls short in the involvement of medical knowledge graphs. That's another challenging area where you can explore. Intelligent virtual assistants. User engagement is a huge challenge, and knowledge-infused learning is a step towards it to solve those challenges. It requires a personalized health knowledge graph, which is a kind of an exploratory world or domain right now in the knowledge graph, and the motivational interviewing, which is another exciting area of research in healthcare, which improves your chatbot experience. And apart from this, the knowledge-infused learning in healthcare, I would say KIL healthcare plus X, where X opens its domain to autonomous driving vehicles, cyber threats, disaster resilience systems, and personal finance. So these are the four main areas I would urge you to explore with the knowledge-infused learning. On the right is just a Gartner hype curve, which tells you that the knowledge graph is just stepping its foot in the world for motivating the researchers to actually exploit this knowledge graph, the semantic knowledge, in improving and propelling the deep learning models. And anything above the knowledge graph is something that you can actually use knowledge graph in those to actually improve their performances and make more sense of your outcome, and rather than simply sticking around with precision recall and F-score. With this, I give my acknowledgement to all the collaborators with whom I worked, my advisor on the left, my co-advisor, Dr. Prasad, Dr. Shailin, Dr. Patak, and my colleague, Or. With this, thank you all. I wish you all the best. So the knowledge-infused learning, we actually are organizing a workshop at the KDD conference this year, which is the submissions are still on. And you can actually also look at other research where I am actually, and together my collaborators are extensively involved in the Artificial Intelligence Institute at the University of South Carolina. Thank you so much.
Thank you very much, Manas. You have the honor of being the longest talk in PyData Salamanca. Congratulations. No,
Thank you so much.
It was a nice talk. We really appreciate it. And usually what we do here is we wait if someone who is watching wants to ask a question. He can just use the chat. But I know there's someone who is already connected who wants to ask you a question. So, Marcos, you can join and ask the question you wanted to ask to Manas directly.
Yes, hello, Manas. My question was about the probability of a PAC learning in how to transform these monotonicity problems to more non-monotonic problems. For example, how can we classify robustness and consistency in order to know if our domain is correct? Is, for example, in a check for hypothesis, to know if our null hypothesis or the alternative hypothesis, in which if we are in the region of confidence, how can we do that from these domains?
Okay, So, Marcos, if I understood correctly, your question is about that you have a problem at hand, and which is basically a non-monotonic problem, and you want to convert the non-monotonic problem into a monotonic problem for better and enhanced classification. Am I right?
It was the other way around, because in this case we are in high monotonic, very high monotonic domains. As if you are looking for some of the context on your data, if they are mental health related,
Yes.
probably they are sending you in this domain. They will send you to very high monotonic responses, and will lead us to a hypothesis. But how to keep this robustness? Because, for example, if it is a fiction, if it is a fiction context, probably the same language, the same semantics used there, will lead us to erroneous hypotheses, and we will need to pick the alternative hypothesis in our statistic inference.
Absolutely, absolutely. So one thing is that Marcos, is suppose you have data with you, or you have a data set. So essentially, what you wanted to do is you want to add some delta noise in your data set. So while you're training a model, right? While you're actually building a data artificial intelligence model, is always test. It's always nice to test with some random noise. If you add some random noise to your model, then it will be able to understand that how much diversity it can handle and how much diversity in the responses is possible. For example, I'm just giving an example right now in front of, if you can see my screen. So this is like about the generative adversarial network. So what essentially this model does is that you have the scene category data, assume that to be, let's say, it has some information in it, you know about those information. You add some noise. The Z1 is the noise that you add, so that the model can be able to adapt itself with some noise in the data set. And something very similar as you, what you can do is something that you are not seen, and that and you want a consistent prediction with that. You actually have those that kind of structure as well in Z2, and you are essentially trying to train two models, which are actually, one is learning about the things that you are aware of, which you can say can be like non-monotonic or monotonic. Another thing will be the opposite of it. And what essentially your model is trying to do is your model is trying to differentiate between those two, and tries to see that to what level of significance can you predict very close to what you already know. So that will actually bring in some diversity in your prediction, but it will not also lose the monotonicity in your prediction.
Thank you.
Yeah.
Okay, we have another question in the audience. So Desai ask exactly, in place of word embeddings, is it possible that we use sentence embeddings? What will be the effect on outcome in terms of chat applications, for example?
Sense-dense embedding, right?
Sentence embedding.
Okay. Sentence embedding. So the selection of word embedding or sentence embedding all depends upon the type of applications for which the chatbot has been made. Suppose I would say that it's kind of an experimenting thing. You can actually go with word level embedding. You can also go with sentence level embedding, but it depends upon your applications. For example, if I have a chatbot which actually asks, in which you are allowing the user to give a long detailed responses, definitely sentence level embedding would be better. But if the responses are very short, I would say to go for word level embedding. Or even if the sentence, if the expression, if the input is way shorter, then I would say even you can even try the character level embedding. So it depends upon the type of input you're getting on the chatbot.
Okay, I think we are past 8 here. It's a little bit late, so thank you very much, Mana. It was a pleasure. And we are going to talk about other stuff later. But just about this talk, it was perfect. Thank you very much.
Thank you so much.
And thank you everyone attending. Bye.
Bye.